Hey, it's a great day, geometry students, because today is the first day that we're going to start learning formally about proofs. I know you're as excited as I am. No, you're probably not. In fact, I'm sure some of you have heard from other students who've been through geometry before. Proofs. Ugh, I hate proofs. Hey, you you withhold judgment about proofs until you learn how to do them, because I know there are students out there who like doing proofs. Yes, there are. Okay. And there's not just one or two. A lot of students actually really like them, think they're quite easy. So make no judgments until you learn how to do this. Okay. Learning how to write proofs, in my opinion, best, most valuable thing you can learn in all of geometry, perhaps in all of math. Okay? Because you can use what you're learning about writing mathematical proofs for the rest of your life, not in math problems, but just in the service of conversation in the rest of your life. It's an extremely valuable thing to understand how to do. Well, let's get going. I'm just going to read a lot of this on this notes page here, but highlight some of it. So, first of all, let's take a little bit of the mystery out of what a proof is. It's just a mathematician's formal explanation written in written form, okay, for how he or she has proceeded from some initial conditions to some final conclusion. Or in other words, how do you get from the stuff you've been given in a problem to the answer of a problem? But it requires explaining what you do every step of the way, not just doing stuff, but explaining what you're doing. Okay. So every part of the proof, which I'm referring to as the explanation, must exhibit three characteristics. It must be clear. What you say in your explanation must be clearly understood. No ambiguity, okay? No vagueness, no fuzziness to it. It must be accurate, okay? A lot of students write things in their proofs that are just flat out wrong, okay? They write false statements. Statements you write have to be accurate, and they have to be relevant. The things that you write in your explanations need to actually be connected. The explanations you're giving must be connected to the problem that you're solving. Okay. I don't know if any of these three characteristics seem like they're obvious to you, but anytime I am taking credit off of a student's proof, I can cite one of these three things. You're not clear. This is not a clear statement here. I don't know what this means. Or this is simply not accurate, not true. And just because you say it doesn't make it true. Or, well, you've said something clear and you said something accurate here, but it doesn't matter in this problem. It has no bearing on this problem. It's not relevant to this problem, doesn't help us solve this problem. Okay. All right. There are different ways to write proofs in mathematics. We're going to stick with one particular form of writing proofs. It's called the two-column form, just because I think that's the easiest to learn. It's the most helpful. So that's what we're going to do, two-column form. So when you write a proof in two-column form, you have two columns, okay, like I'm showing here. Split, not really down the middle, because reasons that you write on the right-hand side are usually much longer than what you write as statements on the left-hand side. So usually the statement column will be pretty narrow and the reasons column will be pretty wide. But statements are, just reading here again, the text, mathematical sentences about specific things in the problem. And here's an example down here. AB is congruent to BC. That's a mathematical statement. It's naming very specific segments. Whereas reasons are general mathematical principles. Okay? And they should always be worded generally and never refer to names of specific examples of objects. And in this course, they should almost always be written in if-then form. Now, we've been learning about if-then statements most recently. Okay. So here's an example. If a triangle is isosceles, then it has congruent legs. That's a general mathematical principle. It's not naming any specific isosceles triangle. It's not naming any legs like A, B, and B, C. All right. But in fact, this reason right here could be the reason that supports this statement that you might want to make in a problem. Okay. When you write your proof, every statement and reason should be numbered, and every statement must be supported by the reason written immediately alongside of it. Okay. This will all make a lot more sense as we go through some examples. So I'm reading through this rather quickly. All right, we're going to keep a running list, or I'm going to keep for you a running list of reasons that you are allowed to use in proofs. And here's our list for right now. This list is going to grow as we go through this unit. But right now, these are the absolutely only reasons that you should ever write in the reasons column of a proof. And these are all mathematical principles that you understand, you are familiar with, you already know these things. There's nothing to learn about the ideas in this yellow box here. You know all of these things already. Okay? So let's go down and actually look at some examples of doing proofs. So here's the first problem. Okay? I've provided a diagram here, 2 segments, 5 points, actually more than 2 segments. We could name a lot more than 2 different segments. MV is a segment, MP is a segment, VP is a segment. There's 3 different segments right there along that line. Okay. So lots of segments in here, 5 distinct points. And when we write a proof, again, here's the 2 columns. Notice the statements column is a little narrower than the reasons column. We always, in step number 1 in the proof, say that if we have a diagram, we say, well, there's a diagram that's been shown here. And I'm giving you that V is a midpoint of MP. That's information I'm providing for you, right? And so the first step in a proof, the first reason that we use to support anything that we know or that we believe is true is, well, this is the given information that I'm starting with. This is the start of the problem, okay? I suppose we could use the phrase, the start of the problem. But historically, traditionally, the way we write the first step in a proof is given, or here's the information that was given to me to work with. Now I've got to prove something that has not already been said, something that hasn't been specifically told to me. Okay. So let's look at the information we've been given. Here's this diagram, and we have that V is a midpoint of MP, specifically segment MP. Right? So what can you conclude from that? What do you know? When I tell you V is a midpoint of this segment MP, what do you know about what's going on in that diagram that I haven't specifically said, but you're probably making the connection immediately in your head? What does a midpoint of a segment do? Okay, yeah, it creates 2 congruent segments, or it divides a segment into 2 congruent pieces, right? Those are a couple of ways of saying what is happening when we have a midpoint in a segment. Let's go back to this yellow box and look at the way I've worded it here. If a point is a midpoint of a segment, then it divides that segment into 2 congruent segments. Notice this is an if-then statement. Right? If you're tempted to write something here, like if you're tempted to say something here like a midpoint divides, okay, stop. I want you to start with the word if in your reason. Okay? But the statement here, I'm going to grab my stylus to write the statement, would simply be that MV must be congruent to VP. Remember, statements are specific. They name specific objects in the diagram, whether they're segments, points, angles, triangles, whatever. But I have to provide a reason now that supports this conclusion of mine. And the reason comes from something that we already knew, that was already stated earlier in the proof, that V is a midpoint of MP. So I want an if-then statement here. If a point, I'm going to write some abbreviations here, PT for the word point. You're welcome to write some abbreviations as long as I understand them. Okay? Don't write abbreviations that are vague. Okay? If a point is a midpoint, there I'm using another abbreviation there, MDPT. I think that's pretty clear what that is an abbreviation for. If a point is a midpoint, comma, then it divides, I'm even going to use an abbreviation here for the word divide, divides, actually, I want to back up. I want to add just a few words after midpoint. I want to add the words of, come on, pen, of a segment. If a point is a midpoint of a segment, and that is what we're being told here, that this point is a midpoint of segment MP, because it is possible to have midpoints of other objects. Okay? And then those midpoints do different things. But if a point is a midpoint of a segment, then it divides, I'm using the division symbol there as an abbreviation, it divides that segment into two congruent segments. There's the general mathematical principle that connects something that I already knew, that a point is a midpoint in this diagram, to something new that hasn't been said yet in this problem. Okay? You have to always be able to do what I just did here. You have to be able to connect the hypothesis of your if-then reason to something that has already been stated in the proof. And then you have to be able to connect the conclusion of your if-then to the new conclusion that we just claimed is true. You always have to be able to do this. When you write proofs, they are in effect self-checking. Okay? Because every time you write a reason, it should be an if-then form, and you need to be able to circle the hypothesis and make a direct connection back to something that was in an earlier statement. And you need to be able to circle that conclusion and make a direct connection to your new statement in that same step. Okay? So we're done with this proof. We said something that hadn't already been said in the problem. It may not seem like all that big of an accomplishment to you. And I'll grant you, it's not. It's not that big of an accomplishment. Okay? But in the early lessons of doing proofs, it's far more important not that we learn more new geometry. That's not what I'm trying to achieve with you today. I'm not trying to teach you any new geometry at all. What's important is that we learn the format of writing proofs and we learn how to write them properly. Trust me, we will get to problems that will be longer and more complicated, proofs that go beyond a step 2 to a step 3, maybe a step 4, a step 5, maybe even a step 6 by the time we're done. And if you don't keep to the structure of writing a proof, you're going to get very lost very quickly. Worse still, when I try to read what you have written, I'm going to get lost in a hurry, and you're going to get no credit for the problem. Okay? Again, what proofs are about is not so much about achieving great math, great new math conclusions, solving really complicated problems. Not at this stage. What they are about is learning to write things clearly, accurately, and in a relevant way to the problem. That's what's most important to be learning when you're first learning about proofs. Okay. I think one more thing I want to say before we move on to the second example. Right here, I used the word it. And that word it shows up in this reason right here. If a point is a midpoint of a segment, then it divides that segment into two congruent segments. Okay. In this English sentence, this word it very clearly refers back to the point. The point is the subject of this part of that sentence. Right? Sentences have a subject and a verb. Statements have a subject and a verb. The subject is the point. The verb is. Okay. This word "it" refers back to that subject. And that's clear in that English sentence if you understand the way English is written. Okay. But I find that too often students use the word it very carelessly. And I cannot tell from what they've written what that word it refers to. And oftentimes they will use the word it multiple times when they're writing out proofs. They'll say things like, it divides it. Okay, now they've used the word it twice. They probably mean two different things by it. And already it makes me nervous to read stuff like that. But since we're doing all this teaching and learning remotely, and you can have the list of reasons, and you can simply copy and paste the reasons that I provide you with into the proofs, you really shouldn't run into any difficulties with the word it, or really with any clarity of what you're writing. This issue right here, clear, that should not be a problem this year, because you can just copy and paste a lot of what you're writing. Okay. All right, let's go on to example number 2. Again, I have given to you a diagram as shown up here, and I am telling you that triangle JYZ is isosceles with base YZ. So what do you know about that triangle that I haven't specifically said, but you know when I tell you the triangle is isosceles? What do you know? Okay, yeah, that's usually the first thing that comes to people's minds, is that it's got to have two congruent segments. Now, specifically, again, we're in the statements column. We want to name the two congruent segments. Which two? Right, JY. My stylus is not cooperating. So JY is congruent to JZ. Now, how do I know it's those two segments? How do I know YZ isn't one of the two congruent segments? And don't tell me because it doesn't look like it's one of the two congruent segments. How do we know for sure that it's JY and JZ? Okay, yeah, somebody said because I told you what the base of this triangle is. Right? Maybe some of you are not remembering that the base of an isosceles triangle is the one side that might not be congruent to the others. Okay? Base does not mean the bottom of the triangle. Okay? The base of a triangle can be anywhere, pointing in any direction, running in any direction. Okay? But when I tell you what the base is, then we know, okay, it's the other two sides that have to be congruent. But again, every time you write a statement, you have to write the reason that supports it. Well, we just talked about the reason that supports it. It's because the triangle is isosceles. But I want you to write your reasons as if-then statements. And if you're not quite sure how to do that, let's just go back to the yellow box again. Okay? What do we have here? Here you go. If a triangle is isosceles, then it has congruent legs. Okay? So let's write that in there just exactly like that. If a triangle is isosceles, then it has congruent legs. I've used a couple of abbreviations again here. I used the triangle symbol for the word triangle. abbreviated isosceles to isosceles. I think those are pretty clear. Then it, and once again, this word it, which I copied right from the reason, refers right back to the subject of the first part of that statement, the triangle. The triangle has congruent legs. And once again, notice how the work here is self-checking. You need to be able to circle your hypothesis. A triangle is isosceles. Is that something that's already been stated in a previous line in the proof? Yes, it is. Right there. You need to be able to circle your conclusion of your if-then statement and connect it to the statement that you just wrote. Congruent legs. And here's two congruent legs. Okay. Oh, yeah, good. Somebody's saying, hey, Mr. Nortillo, couldn't you have said something different? And yes, we could have said something different. Or we could say something in addition to what we said in step 2. We could write a step 3 and prove something else besides the fact that JY is congruent to JZ, right? What else do we know about isosceles triangles? They don't just have two congruent legs. They've got two congruent angles also, okay? Now, I can get away with single letter names for these angles. Angle Z is congruent to angle Y because there's absolutely no ambiguity about what I mean by angle Z, right? I mean, if I had a picture that looked like this and there was a Z there, then writing angle Z is very confusing. Would we be talking about this angle Z, this one over here, that one there? You'd have to give me 3 letters in the name. Otherwise, you're not being clear. Okay? You got to be clear. But these angle names are clear. There's only one angle Z in this diagram, and there's only one angle Y in that diagram. So that's a clear statement, and now I need a clearly written reason to support it. Go back to my list of reasons. Here it is, this one right here. If a triangle is isosceles, then it has congruent base angles. Okay, so if a triangle is isosceles, then it has congruent base angles. Once again, you need to be able to connect a hypothesis of your reason. Triangle is isosceles. Is that something that was already said in a previous step in the proof? Yes, it was given in the very first step. And then the conclusion, congruent base angles. Is this statement naming two congruent angles? Yes, it is. Okay. You may feel like I'm pointing out so much the obvious here, but I can't tell you how often I get work turned into me, and a student will write something like, then it has congruent legs, and in their statement column, they won't name any segments. They'll name angles, or vice versa. They'll say if a triangle is isosceles, then it has congruent angles, but they'll name 2 segments. I mean, they'll do that kind of thing, which may seem like, how could anybody do that? But they do it all the time. So I don't think it's so obvious for me to be saying these things. I think it's important that I draw your attention to them in the early going. Finally, number 3. Again, I've given you a diagram as shown up above here, and I'm telling you that segment WK bisects angle CWD. Now, we all know what bisecting means, generally. It means dividing something into 2 congruent parts. But you have to pay careful attention here to what I'm telling you is being bisected. Because look at this diagram. It looks like there are lots of congruent things in this diagram, doesn't it? Looks like it. I mean, it looks like this segment's congruent to that one. Actually, it looks like all four of these segments are congruent to each other. Wouldn't you agree? Doesn't it look like this segment is congruent to that one? Doesn't it look like this segment is congruent to that one? For that matter, doesn't it look like there's lots of congruent angles in this picture also? Doesn't it look like this angle's congruent to that one? And doesn't it look like this angle is congruent to that one? For that matter, I think these two look exactly the same as those two over there. And oh, it looks like those two up there look congruent to those two down there. I mean, it looks like there's lots and lots of congruent things in this picture. But looks like is not good enough. Okay? Don't you ever write a reason that says, well, it looks like it. Okay? There's only one object in this diagram that I am telling you is being bisected, and that is angle CWD. Where is that angle? It's that large obtuse angle there. That's the only angle, which looks like it might be about 150 degrees. That's the only angle in this picture that I'm telling you is being bisected. And so the only conclusion that we can come to is that this angle is congruent to that one. That's the only conclusion we're allowed to make here. There are, trust me, much as it looks like there's lots of other congruent things in this picture, there are no guarantees. It would be easy for me to draw a picture like this with all of these lines going in all these directions and two congruent angles down there, but there are no other congruent parts anywhere. In fact, I think I'll draw you one before I'm done with this lesson. Okay, but the only statement we're allowed to make here now, and now you need 3-letter angle names. If you write angle W is congruent to angle W, here's what I'm going to write on your work. Duh. Okay. How could angle W ever not be congruent to angle W? Looks to me like you're naming the exact same angle and saying an angle is congruent to itself. Well, of course it is. Tell me something I don't know. Okay? Really not good. Not clear what you're saying there. Okay? I mean, I take it back. It's clear what you're saying there, but that's not what you mean to be saying. Okay? What you mean to be saying is something like this. Angle CWV is congruent to angle, let's call it VWD. Now, each one of those angles that I just named has a different name for the same angle. This one could be called angle VWC. You can turn those letters around. It's still the same angle. Actually, for that matter, you could call this angle CWK. That would be a different name for the same angle. Right? So there's lots of different names for these two angles. But whatever name you give me, it better be identifying the proper angle in the picture. Okay? And now the reason we want to write is, and again, we go back to our collection here. Here's 2 reasons that have the word bisect in them. If a segment bisects another segment, this one starts if a segment bisects an angle. Well, which one do we need? What were we told in this problem? We were told that a segment is bisecting an angle. Right? So, if a segment, you know what I'm going to do here? Show you what I'm going to do. I'm going to erase all this stuff, and I'm going to grab this text box tool here because it looks so much nicer. If a segment bisects an angle, I just can't use those nice picture abbreviations, then it divides the angle into 2 congruent angles. I believe that's how it's worded. Let's go back to the yellow box. If a segment bisects an angle, then it divides that angle into 2 congruent angles. Yes. Okay. So there you go. There's my reason. And again, let's check. Let's check. Can you circle the hypothesis? If a segment bisects an angle, is that something that's already been said in the proof? Yes, here it is, a segment bisecting an angle. Now circle the conclusion. We got two congruent angles. That matches the statement that we just gave. Okay? In the homework, you have 6 proofs to complete. Right? Here they are. 1, 2, 3 on the first page, 4, 5, 6 on the next. You will not need a reason in your reasons column other than what's in this yellow box here. Everything you write on the reasons side of your proof should come right out of that yellow box, word for word. Don't change a thing, or you risk becoming unclear or inaccurate. Okay? You can still be clear and accurate and be irrelevant. Okay. But at least if you copy these statements word for word, they will be clear and they will be accurately stated. They will be true things. Right? I am not going to post the answers to these proof problems. Or, I don't know, maybe I'll post a couple. But next Zoom class, I am going to ask you for your statements and your reasons. And we're going to go over these in Zoom class. Don't miss it. It'll be a very important lesson. Okay, so I'm only just going to post a couple answers. All right, that's it. Yet after the homework. Actually, I believe I might change my mind about that posting the answers because I believe you have 2 video lessons to watch and 2 homework assignments to do between now and the next Zoom class. So I think what I'm going to do is I will post all of the answers to this homework assignment, but I will not post all of the answers to the second homework assignment. And we'll talk about those in class. That's what I think I'm going to do. All right? Get after it.